The game of chess is known to attract very intelligent people as it requires focus, strategy, and a lot of practice. Garry Kasparov is famous for being the world chess champion from 1985 to 2000. During that period of time, both IBM and Apple were building powerful machines. Those of you of a certain vintage will recall the two Apple PET computers shared by your entire school, or the 8 IBMs in the computer room, where you could play games such as chess, checkers, and Othello against the computer. Over time, the operating systems improved, and so did the games. This growing technology had the world abuzz with amazement at the potential of these machines to be smarter than humans. IBM created a customized computer called Deep Blue, specifically for chess playing, to evaluate this theory. In 1996, Kasparov played a game of chess against Deep Blue under regular time controls, and the computer won a game. Deep Blue's victory was hailed as a sign of superintelligence, that the machine is smarter than the human. Kasparov later explained that the reason the machine was so successful is because it makes fewer mistakes in a closed-form problem. Funny enough, so do we. Welcome to We Are the Machines. I'm Dr. Deitra Sawh. This podcast is for those who want to use artificial intelligence. Through anecdotes and phrases, you will be fluent in AI in front of the executive team and at the dinner party. I explain how machines learn in the context of human learning and will arm you with the right questions to be asking the machines or those who are building your machines. You will sound like an AI rock star by the end of each episode. Let's get started. The game of chess is an example of a closed-form problem in the world of computing. A closed-form problem is one with defined rules, constrained paths to reach a goal, and can be codified or described to a machine using defined language. For example, board games are designed to arrive to an eventual end. You cannot play Sorry or Connect 4 infinitely, even if that end is a draw or a tie. The rules are clear, and the machine can be programmed to say, okay, it's a tie. Do you want to start again? Other closed-form problems which have been automated are the most direct route from place A to place B, and, although it feels infinite when you are hungry, your Uber Eats app. Your flight tickets to Paris are a closed-form problem. Even your real estate options come with very specific conditions, such as dates, times, and location. They are all problems where there is a finite number of options to reach the goal. Even you define yourself within a constrained set of language. Your response to the casual greeting in the workplace of, "How are you today?" is met with one of, "I'm good, how are you?" "I'm okay," or a smile. And social media has done an excellent job of streamlining human emotions to a fixed set of emojis. In contrast, an open-form problem would be urban planning, or constructing an investment portfolio, or what is the best career path? There is no correct answer to these problems, nor clear paths to get there. Now that you know the difference between closed and open problems, let's test your decision-making. What is an easier decision for you? Question 1. What do you want for dinner? Or, question 2. Do you want coffee or tea? Question 2 is likely easier for most people because it had 2 options, coffee or tea. Because of the limited options, it is considered a closed-form problem. You can see that a closed-form problem is easier for you too. Kasparov understood that the machines analogously compute closed-form problems the same way we do, but because it is programmatic, the machines will make fewer mistakes. You can use this knowledge to harness the power of AI by first determining whether your problem is closed form. Usually, these type of problems have a clear goal, a destination, an explicit monetary level, maybe even finding the only one left. and rules on how to get there, like roads versus transit, low versus high interest paying assets. If your problem cannot be demarcated easily, then create some rules so that you can solve your problem under some constraints. This will let you see how it behaves in a closed environment and understand better how AI behaves on your data. In fact, AI experts every day are trying to describe open form problems into closed form problems so that the machine can solve it. If we follow this path far enough and treat all problems as closed form, we will end up without any variety or nuance in problem solving. In engineering, we say we will lack ingenuity. And this is how we will be like the machines. And now a plug for humanity. We've already given up our closed form problems to the machines. Let's try to use our brains for the open ones. Our imaginations are the most open form we still have. Use your imagination before it's gone. We'll see you next time on We Are the Machines. I'm Dr. Deitra Sawh.